What we did last time is the concept of analytic curve. Let me repeat just informally. It says that if you have a curve and this curve is said to be analytic curve, if for each point on that curve there is an open neighborhood of that point and there exists a conformal map from a disk with center on the real line from disk D onto this U such that the image of this real segment in this disk is nothing but is the part of the gamma that lies inside this open neighborhood U. Then we say that it is it is a what you say analytic curve and free what is free analytic curve of free analytic boundary or a free analytic curve of a boundary of a domain. If you have a domain, suppose you have a domain D, and then we say that a part of it uh, is a free analytic curve if at any point we are able to find a disk such that the one part of this disk lies in the domain D and the other part do not lie in the domain D. That's the free analytic curve. Now for free analytic curves, we have a version of a Shiva's reflection principle, which I'm going to state. And what it is that suppose D be a domain and let gamma be a free analytic fair analytic boundary arc of D. Let F be an analytic function on domain D if mod of Fz tends to 1 as Z in from the domain D tends to the gamma, then it says that F extends to be analytic in a neighborhood of gamma, and the extension satisfies the following identity. Extension satisfies the reflection of the point Z, image of it will be the reciprocal of the image of the conjugate of Z in neighborhood of gamma. So we have this situation B. We have a free analytic boundary arc of a domain. And the domain we have an analytic function, and we want to extend this bounded function beyond the boundary. And how it is? See, we have a domain. Suppose this is a domain, and let's take this certain part to be. Let's take this part of the boundary to be gamma. What this says that we have analytic function on this f defined. We have a function f which is analytic on domain D, and uh, whenever a point in domain D, if that point tends to this part of the gamma, if z tends to this part of the gamma, then in that case mod of fz will tend to 1. That is to say that fz tends to the boundary of the unit circle. You can visualize in this way that in that case f of z will tend to the boundary of the unit circle either from the outside or from the inside. This is how you can. Then it says that where gamma has the property that gamma is a free analytic arc. It's a arc of the boundary. Then it says that we can extend this function to be analytic on a neighborhood of gamma. What is the neighborhood of gamma? Neighborhood of gamma is some open set which contains this gamma, and obviously that open set, since it's an analytic part, since that open set will be of this kind of this form. सो आपके पास फंक्शन एनालिटिक डोमेन पे था, बट एनालिटिक पार्ट की एनालिटिक करो की वजह से ये फंक्शन की एक्सटेंशन यू हैव बीन एबल टू डिफाइन दिस फंक्शन बियॉन्ड दिस डोमेन डी, जो इसका डोमेन ऑफ एनालिटिसिटी, इसके बियॉन्ड आप इसको एक्सटेंड कर पाएंगे. This is the context of this theorem. This is the context of this theorem. We will be able to extend this function to be defined on this part as well. ये जो मैंने ग्रीन मार्क किया है, इस पार्ट पे भी हम इस फंक्शन को डिफाइन कर पाएंगे. और इस पार्ट पे सिर्फ डिफाइन ही नहीं कर पाएंगे. इट विल नॉट बी जस्ट अ फंक्शन, इट विल बी अ एनालिटिक फंक्शन देयर. इट विल बी अ analytic function there. So this is the context of this theorem. And on this part, on this u, let this be some neighborhood. On this part, this extension will satisfy, because along this gamma we will be able to find the reflection of every point. क्योंकि ये फ्री एनालिटिक आर्क भी है, तो आप किसी भी पॉइंट की रिफ्लेक्शन भी आपको डिफाइन होगी. तो ये रिफ्लेक्शन इमेज किसी भी रिफ्लेक्शन की होगी तो उसकी that will be equal to the image of conjugate of z, not conjugate z. This is whole of conjugate of f of z. So this is the context, this is the idea, and how we are going to deal with it. See, let's fix some point on this gamma. Let us fix some point on this gamma. Okay, and consider the conformal map. See, we have this gamma. Let me again redraw here because I will have to flip again. Okay, better to take, yeah, that's better to redraw here. Let me take just a minute. Let this be a part of the gamma. And we have chosen point z not here. Then since it is analytic, you know, ये करू एनालिटिक करू है तो आपको एक ओपन सेट मिलेगा, एक ओपन नेबरहुड मिलेगा u. ठीक है, तो डेफिनेशन क्या कहती है एनालिटिक करू की, कि आपके पास फिर एक डिस्क से लेकर, let this disk be D, you will have a conformal map from this disk to this open neighborhood this, such that आपके पास image of this segment is the part of this curve gamma that lies in this u. So let this is the function centered. So you have this kind of setup. Now what we are going to do, I'm going to define a function, and I'm going to define a function g, and this g is to be defined on this disk D. I'm going to define on this disk के ऊपर अभी एक function हम define कर रहे हैं, and how हम कैसे define कर रहे हैं इसको, Just a minute, give me a minute. uh, we have to define it to be log of, we have to define it to be g of zeta to be, since you see z of zeta will be, uh, you have zeta in this disk, you have zeta here, and z of zeta has to be in this open neighborhood u. This is the conformal map, and it has to be on the one part. We have to be defined on the one part, because what is the relation between this u and t is that, let this to be, as discussed. Just I need to mark, one this u has to be, u gets divided into two parts. One part of the disk, one part of this u is mapped onto the top of the disk, and suppose this is the top of the disk, and zeta we are taking in this top of the disk, and its image will be inside. We are considering in such a way that this half of this u lies inside the domain d, so that z of zeta lies in the domain d, and once z of zeta is in the domain d, then f is defined there. I can apply f on it, and once I apply f on it, what I'm going to do, I'm going to apply log on it. I'm going to apply log on it. So this function is defined. It is then g is defined on one side of this disk. That is the, it can be upper half or it can be lower half of this disk, depending upon which part is mapped onto the part of the u which lies inside the domain d. So it is defined there. Now let's see what is the real part of this function, and what that function satisfies. Now now the real part of g of zeta, you know what is the real part of a log function? It is log of, natural log of mod of f of z of zeta. And you see, whenever, according to the hypothesis, we have this condition that whenever a point approaches in a domain D, whenever a point approaches to this part of the gamma, then the modulus of that point, the modulus of the image of that point goes to 1. And hence, log being a continuous function, log of that, modulus of that will go to 0, as zeta from this part of the disk, uh, no, not zeta in that part, it has to be, whenever zeta from this disk, whatever part we are taking, converge, approaches to some point on this segment R. And because any point, whenever zeta approaches, whenever zeta from this top half approaches to this segment, then this conformal map will uh, make this z of zeta to approach to the gamma. This part, actually, we are restricting to this. Okay, we have this situation. So we have g of zeta being an analytic function, g being an analytic function on this disk, and you know this disk is a symmetric. Disk is always a symmetric with respect to the real axis, and its real part approaches to 0 as zeta, the point tends to the boundary. Now we can apply the Shiva's reflection principle. And now we have all the hypotheses for Shiva's reflection principle for analytic functions. Hence, by Shiva's reflection principle, What Shiva's reflection principle states? Shiva's reflection principle states that G has to be extended beyond the boundary. G extends to whole of the boundary, whole of the disk D naught. It extends to whole of the disk D naught. Now G was defined only one part of the disk, whether it was top half or it was the bottom half. So it extends to D naught, and if G extends to D naught, hence exponential of G, E of GZ, which comes out to be, G की definition से देखिएगा, G की definition is log of something, and if you take the exponential, you will get only this f of z of, it has to be zeta, f of z of zeta, and it extends uh, to whole of d naught, and in particular it's z of zeta को अगर आप z से replace करें, तो what you get, we have finally that this function e of g of z, which is equal to f of z. Now z lies in the open neighborhood U. It extends to U, and that means f extends to U. F extends to U, and this extension is always unique. So we have this extension part done. Now what we are going to do, we are going to check out this inequality, this identity that has to be satisfied. And we just considered a point here, but we need to it to be done on whole of the arc. But if you choose, as discussed already, if you choose another neighborhood, I can choose another neighborhood of this arc, and in this way this extension will be analytically continuable throughout the gamma. Okay, because on overlapping region this extension is going to coincide, and the uniqueness principle, on the union of these two open sets the function will be extendable to this union, and so on. So let's now look at this thing. Next, let us consider a function h of z defined as fz star whole conjugate. Now let's first look at this thing. So we have, first let us look at this. We have z, then from z to z star we have, this is a reflection map, this is a reflection, and then and you know this reflection as discussed is an anti-conformal map. This is anti-conformal, this is anti-conformal, and from we are applying now f over this z star. Whether it is conformal or not, that is something that needs to be discussed. And then we are taking the conjugate, then another map, we are taking it conjugate of it. So you see this function which is defined from z to here is a composition of three maps. It is a composition, और ये जो दूसरा मैप है जो z f z star को conjugate करता है, this is also anti-conformal. This is anti-conformal map. So we have the composition of two anti-conformal maps, and we have a third map also. And third map क्या है? Third map f है. And f is analytic function. You know about that. F is analytic, and if at a certain point, if at some z, derivative of f at that point is non-zero, then we know that that function is conformal there. Then that means at those points this composition is made up of two anti-conformal maps and one conformal map. It is conformal at the point where derivative is non-zero, and you will have this composition anti-conformal, conformal, and anti-conformal and conformal is anti-conformal, and the composition of two anti-conformal is the conformal map. Then we see that this function h being made up of two anti-conformal maps and a conformal map at the point where derivative is non-zero, and hence this function being a conformal map, what you say, this function being a conformal map, and it can be seen that it is differentiable also. because f is differentiable and all the other compositions, this z star, and they are the differentiable functions. They are continuously differentiable functions indeed, and hence there is a result which I'm going to state at the later stage, that if we have a continuously differentiable function on certain domain, and the gradient of that function is non-zero, we are taking this gradient of non-zero will come from when the derivative of f will be non-zero, and if the function is conformal there, then the function happens to be analytic, and hence this h is analytic. H is analytic on this part u, जहां पर भी हमने इसको h को define किया. We have defined this h on this, ये कर्व था u पे हमने इसको define किया. It is analytic there, and but it is analytic at only those points where the derivative is non-zero, but this function is analytic, and it will, how many zeros it will have, I don't know whether it will have finite or infinite, but it will have isolated zeros. It will have isolated zeros, and the function is continuous there, and the function is continuous there, and it is continuous at the point. Now note that it is continuous, h is continuous at z where derivative of fz is equal to 0. So that means h is a continuous function at these isolated points, and these are you may treat them to be isolated singularities, but this isolated singularity, if the function is continuous there, so it is neither what you say, neither it is a pole nor it is a essential singularity, then this isolated singularity has to be removable singularity, and if it is removable singularity, then a removable singularity means h is analytic at those points also. So these points happen to be removable singularity. So h extends to be analytic at those points also. Be analytic, and at those points mean it is analytic on whole of this open set U. Okay, this is no. So now let us take some point z in gamma. Then on the gamma, reflection fixes every point on the gamma, and also by hypothesis mod of fz on the gamma is 1. Hence h of z, which is defined at this point, which happens to be f of z star whole conjugate, but this z star is equal to z, so this is fz whole conjugate. You just multiply it with fz and divide it by fz also. It will not be 0 because its modulus is 1, and on numerator you will be left with fz, and denominator will be mod of fz square, and mod is 1, hence this is equal to f of z. So that is, you will have on gamma this analytic function h is equal to f, and this gamma is a curve, it doesn't have any isolated points, hence by uniqueness principle, it follows that h and f are identical. H is equal to f everywhere wherever it is defined, and h is equal to f means you have this f of z is equal to h की definition क्या थी, f of z star whole conjugate, this is equal to, which implies that आप क्या करो, आप conjugate करो दोनों side से, और fz conjugate will be equal to 1 upon fz star, and just to match the identity mentioned in hypothesis, you will have fz star equals to 1 upon f of z on the neighborhood of the curve. This is what it's all about, this reflection principle. Now I'm here to take your questions. If you have any questions, you can ask. We have enough time to take your questions. Bolo. So no question.